Hello everyone, welcome to another episode, and as usual, half hour before the stream started, my streaming software didn't want to start, so I restarted it and it seems to be working fine now. So let's see how it goes. Can somebody confirm that you can hear me well? Because I use, as usual, different setup. So please say yes or no. Yes is better. So this time I'm also experimenting with streaming to LinkedIn. I have no clue if it's gonna to work. Yeah, it looks good. It works. Okay, cool. But still, can somebody confirm that you can hear me? I don't hear myself. Yeah, I don't hear myself. So please write something. Yes, okay, good. Thank you very much, Pratik, for confirming. Good. Okay, so then let's move on. Um, okay, let me close all of this stuff. Right, okay, so the subject of this live stream is again Spacelift in action. Last week I was able to accomplish some things, and for this episode I'm gonna to pretty much continue it, and hopefully I will show some uh, things which will help you to get started and actually use Spacelift in a rather effective way. Uh, uh, I think I will show some things which I should not be showing because it's like black magic, and when you look at it, you may think that, oh my god, why I'm even watching this, because it's not good practice, bad practice. I don't care how you call it, honestly, but it's something what you need to know, especially if you are working with technologies which are not very well, how to say, developed um, towards the same goal. I'm talking about Terragrunt and Terraform automation systems like Spacelift and others. Terragrunt has its own opinions about different things. Spacelift has its own way of thinking. Integrating this is not very straightforward, but nevertheless, I will try to show it to you. So yes, hello Saul, hello Yuri, hello Tanya. Good. Let's see. Uh, let's see. Let's see this one. Just next week, I'm gonna to be in Stockholm, and yeah, it's gonna to be awesome AWS Summit. I'm really looking forward to meet some of you there if you're going. It's a great place to be and great place to meet. So yeah, we can see there, and then pretty much the same day or next day, I'm going to Berlin, and it's gonna to be another AWS Summit. So if you are there, we can talk and we can chat. And week after 17 and 18 of May, there will be a DevOps Days Ukraine, Stand with Ukraine, and I'm one of many speakers who are gonna to give talk there. And well, the title of my talk is actually Terraform Thinking Aloud. And when I see this written, I wonder if I should leave it like this, or should I change it to allowed as given permission? Because Terraform and thinking aloud, or Terraform thinking aloud, for me sounds rather similar, especially in a way how I pronounce it. So nevertheless, it's going to be an Ignite talk about things which I which I which I think are quite relevant. And again, I'm not affiliated with HashiCorp. I'm not even HashiCorp ambassador, so I can say pretty much what I want. But believe me, I will not say anything bad or anything what I don't think I should be saying, as I have always been. So, nevertheless, please go to DevOpsDays.com.ua and see this awesome program. Click register, and most importantly, click donate, and then donate some money to awesome funds. Well, these funds are somewhere. Yeah, these funds are doing a lot of things for Ukrainians. Okay, let's move on. This is for Ukraine. If you want to support me and then I support Ukraine, you can always join as GitHub sponsor. There are 40 people and, well, organizations as well. So thanks everyone for supporting me this way. And yeah, that's pretty much it. You can go to my GitHub profile and select whatever tier is more appealing to you. If you're a big organization where you use some work which I have developed over years, don't hesitate to select something bigger than for humans for like 10 and 50. But nevertheless, everything is highly appreciated. So that's it. Okay, so let's make a little bit summary of, yeah, and the last thing which is kind of related. I have not been streaming development of Terraform AWS modules for quite some time, and there were a lot of issues open. Well, issues are always there, but more importantly, I have a lot of things which I want to fix and want to improve. So I will have at least 2 streams, 20 and 27 of May, where I will be focusing exclusively on development of Terraform AWS modules. So if you have any issues or questions or whatever, just join that time and we can talk about it. So that's it. Okay, now let's talk about what I have been able to accomplish last week. And then from that one, I will kind of move on and explain what's going to happen today. So in short, the summary of the last episode is the following. So I have made a Spacelift meta repository, which is a downsized copy of this repository, which is a little bit bigger, and it contains meta configuration for repositories, teams, files, and so on. And it's just a little bit bigger, and there are a little bit more configurations in it. So as you can see, it's a little bit hard to navigate through almost 500 lines. So I made it smaller, and where is it? This one. And what it's here, well, there is a folder called Spacelift Terragrunt, which contains configuration for Terragrunt. We'll be looking into that one a bit later, of course. And then there are folders for each individual Terragrunt stack. One is main, which contains configuration for repository, and another one files, which contains something new, what I'm going to show today. More specifically, it contains dependencies. So this is probably one of the most used and appreciated feature of Terragrunt, where we want to explicitly specify that something should be created before this stack. And in Terragrunt, we can specify dependencies as a list of paths where Terragrunt has to be executed prior to this current stack. Okay, I also looked into some OPA policies. I can show them here. Policies. So I looked into some policies which yeah, some policies. Anyway, I will show this a bit later too. And I also showed workflows for pull request and how it is handled in Spacelift, so that we can run workflow by just clicking trigger button here, or by committing something, or we can also do what is called local preview. Yeah, when we just want to execute Terraform or Terragrunt remotely. And I also showed pull requests. Well, currently there are no open pull requests, but there were some. And as soon as they are merged, then they disappear from here. Well, I think it's quite a broad range of workflows supported by Spacelift, so there is not much to talk about today. Well, that was last time. So what I'm gonna to look into today is how to go through policies, how to debug them, how to run them, and well, how to work with OPA policy within Spacelift context. It's a huge topic. I'm gonna to kind of probably need at least one more stream just to talk about OPA policies, but for now that's it. And I will also look into certain task commands to allow certain individuals or certain things to be performed as like ad hoc commands. And I think most importantly, I will show some dynamic configurations for Terragrunt projects. And how I will show this, yeah, you will see that it's a little bit too magic, I have to admit, but it works. Okay, let's start with some code, probably, just to kind of remind what was happening here. Let's see. Does it work? No, it doesn't work. Yeah, it works. Okay, so here is my configuration for the Spacelift. As you can see, folder Spacelift Terragrunt. Most importantly here is creation of several Spacelift stack for each Terragrunt folders. The way I identify Terragrunt folders was I was looking for Terragrunt HCL file, and every place where Terragrunt HCL is located, as you can see there are 3 of them, then I'm creating 3 stacks. Very simple, but it works. And then I set label Terragrunt, and that's again work. And since I want to talk about policy, policy is again Spacelift resource, so there is module for that. And I'm making 3 policies, and then I'm attaching them using Spacelift policy attachment to each stack. So that's happening here, as you can see. Nothing very complicated, right? So now let's look into how this is actually happening here. I'm gonna to trigger run from user interface, but I can do this in multiple ways, by committing change or by calling an API. It's just easier to do this visually. So if I go to, let's say, GitHub main, where configuration for GitHub repository is, and I click trigger, that's where the magic is happening. So the first thing which you can see here is it says control task commands. This is policy of type of approval type. It's gonna to jump a little bit here, but once it's finished, then we can see that this policy here has approval type, which means that we can control using policies what kind of things has to be performed. Not performed, what kind of action overall in Spacelift can be performed. In this case, since this is not task, then it means it is approved. And here is a simple way how to show that, like how to navigate overall with policies. When we have exact run like now, the easiest way is actually to see policy body here, sampled input, which means exactly the input which was received at this stage by Spacelift. So if we make any changes here, and if we make any changes here, for example, we can click simulate button, and we can see exact result how this was executed using this input. And yeah, that's pretty much it. On this specific policy, it's very simple, right? Let me show a little bit more complicated policy. No, not this one. What was the type of the policy? It was, yeah, it was push policy. Well, git push policy is executed at the very beginning to identify what kind of stack has to be performed. So here you can see approval was executed at the beginning and it was approved. So then it proceeded. It did something. Well, doesn't matter what exactly it did right now. And then another policy, which is trigger policy, was executed. Now you can think about, hey, Terragrunt already handles some dependencies and trigger policy is doing the same things. And yeah, that's where I spent some time actually thinking about dependencies, the way they're implemented in Terragrunt. In Terragrunt, as you remember, when we have the configuration for individual stack, we have dependencies. And the period or the time when these dependencies has to be executed is actually before the main code of this stack has to be executed. So think about this as pre-dependencies or dependencies pre-plan or before plan, right? So that's the whole point. And normally in Spacelift, trigger policies are executed at the very end. I mean, after something happened, then trigger policy is evaluated to decide whether something has to be executed after. So if I run simulate now, it says trigger is empty, which means nothing has to be triggered based on this input. If I do changes in this input and policy, I can easily modify this one. This is a very simple and very effective way to write some policies here. Maybe not the most effective way when you have to write something more complicated, but it works well. Let me show one policy, which is another type, which is git push policy. So to do that, I need to go to my code somewhere here, and I need to just make small change. Let's say, where can I make change? Well, for example, if I make change somewhere here, right? If I add some new content. So I modified content of this file, and yeah, that's pretty much it. That's what I want to change. So now if I want to git commit -a updated readme file, and I push this one. So what exactly is happening right now is, sometimes people say, is not what you think. No, it's actually exactly what you think. Well, you change code in one project, and if we look into UI and if we look into stacks now, we can see that GitHub files has been picking up this change, and it's doing something, right? If we look into this change, that's exactly what has happened. So push policy was evaluated, and push policy has been executed at the very beginning, because it was executed to evaluate whether this was inside of project root or not. Since I changed file downstream, I would say, that's another change which I have kind of implemented. And specifically, what this track policy, what is git policy, no, git push policy is doing, it is identifying whether this stack was affected based on specific criteria, what files were changed. So here we have affected files, and these affected files, that's exactly where I made this change, right? And another thing which I added here was pretty much this line, where affected will be true if all of these expressions are true. So when this regex match will be true, start with and end with. And I added this regex match specifically to track just one folder. which means that if there are changes in a folder which is internal, I don't want to trigger all stacks which are upwards. So if I now run this simulate, and I can see track, no, track, is it track? Yes, it is track, because it says here track. It says track true, and in some cases, oops, it still says track true because I'm actually in the right place. But if I would be running this inside of this GitHub, is it? No, it's not this. Well, anyway, you understand that if I want to control that my tree structure is executed only if changes are inside specific location, then I need to make sure that I'm matching this project root file specifically with the file path of affected file. So no subdirectories will be applied. Okay, so this is how push policy is executed. And again, it's quite simple to make any changes here, to click simulate. Once you are happy with whatever you wrote here, you have to update it inside of policies. Again, you can use Terraform resources for that, or you can go to policies here and make changes there. I prefer to make it through Terraform, well, for quite obvious reasons. So yeah, that's pretty much about policies. Yeah, one extra thing, which especially if you're starting with policies for the first time, you will be surprised. Slava Ukraini, Vitaly. You will be surprised how hard it can be to debug something. Well, even to write this kind of line, which I added since last episode, you will have to do something, right? That's really helpful that you have sampled input. By the way, sampled inputs are available because there is this sample true. If I go to policies, let me show it from another angle. And here is this push policy. You see that it's somewhere here, right? You can you have an understanding of how it was here. If you click edit here, you can edit this code here, but you cannot actually update it, or not update it. You cannot execute whole like end-to-end cycle to get new samples. What you need to do is that you need to click this hide simulation or show simulation panel, and here you have sampled previous outputs. So specifically, if you want to see why this was successful, marked as track, which means that it has to be proceeding with the execution, and why some of them are ignored, you can see previous samples, click simulate, and you can see, oh, that's why you changed this file, and that's why it was evaluated as track. If I look into another sample, then obviously it will not be. So now let me just explain briefly how to write this magic thing. Well, for me, it's kind of hard to explain probably, but open policy agent. Let me go there. I mean, why it is hard for me to explain, because I'm not a big expert in OPA. Every time when I need to write it, I spend quite a lot of time to make it what I want. So yeah, language itself is not very simple. But as I showed last time, you can learn it through documentation, or you can go and read academy.com OPA Rega, and understand how expressions should be written, and yeah, how different Rega rules will be evaluated, and so on. So this is very helpful. And once you read all of this information, and you know that there are a lot of different functions built in inside of OPA, you can do quite a lot. What I prefer to do here, and when I need to write something like this, is that I simply do print and then, let's say, file path. And then I click simulate. And it says API error. That's because, well, it was trying to evaluate, but something unknown came back. That's exactly what I need. So this is how my print operation works. And I can put more errors like this. So print, and then let's say I want to figure out how this expression will be evaluated. I see, okay, that's how it's going to be written. And I can do this line by line print statement. Maybe not the most effective, but it's quite nice to be able to use UI. If you're using more sophisticated IDE like VS Code or IntelliJ, there are plugins for that, and you can execute OPA eval locally, provide sampled input, and provide policy, and do pretty much the same. I'm just showing you this magic print statement, which can be useful without committing all of this. So here, as you can see, the last statement says true. That's exactly what I want. This means that this reject match was evaluated correctly, and that's what I want. If I suddenly want to change it, let's say I affected this file and I want to simulate it, I see that now it's false. Why there are false 3 times? That's a good question. Yeah, I don't know why it is 3 times. Well, apparently it was executed several times. Yeah, that's why we see it 3 times. No, okay, jokes aside, print statement is your best friend from now on. And if you click simulate, you will see this is in correct view, the way how Spacelift expected. So that's good. Okay, so this is how you can debug, and you can provide different sampled inputs here, and they will be evaluated. And yeah, that's how it is. Okay, I think that's pretty much it about policies. Let me show just one more type of policy which is helpful. Or actually, let me show another feature which is very useful. So imagine that I have this stack GitHub files, and then we will go to more kind of juicy part of the live stream, which is Terragrunt dynamic dependencies. So let's imagine that I have this stack where I configure some files. And by the way, if I go, let me just try it. This is the description of this stack. Let me just run this one and see if it's gonna to be no. Okay, I was thinking that this description will be visible somewhere here because, well, for some people it may be helpful. Even for me it's helpful because I may be lost in this encrypted name GitHub files. I would prefer to see something more human friendly, but well, it's just me, so I will have to talk to the guys. Okay, so imagine that GitHub files is managing something. We can click on resources. We can see that there is one resource with type or with name GitHub files. Where is it? Yeah, it's called README. We can see some Terraform specific information. Well, pretty much it. We don't see content of this file, right? We see this one. I don't know what is it. Yeah, it's not what I need. But yeah, I have information about this resource. Now what I want to do is that I want to be able to run certain tasks. So imagine that tasks can be what it can be, exactly, Terraform import, right? How we can do this? Well, we can run Terraform import and then whatever we want. That's one way of doing it. Of course, this command has to be pretty well known by the developer, so maybe it will make sense to use some sort of wrapper on top of it with certain inputs. But what will stop me from doing it? I don't know, Terraform, destroy, and lose everything. Let's do this. Rejected. Why it is rejected? I want to destroy everything. Well, it was rejected. Well, it's a bit tricky, I have to say. You don't know why exactly it was rejected, but I mean, there is no specific line which says that the evaluation of, let's say, this rule led to rejection. But of course, you have me, so I can explain why it was rejected. Well, it was rejected because approval policy is, according to name, is executed pretty early on, right? Before actually doing anything. And it was rejected because, well, it was rejected because none of these commands were used. So as you can imagine, it's looking for strict match. I mean, this is how it is. If I would be using some regex match and then if command starts with Terraform and then let's say it starts with Terragrunt import and then whatever, then this is allowed command. I just need to update this rule, OPA rule. For now, I mean, for the sake of this demo, I'm expecting or I'm allowing only these 3 commands. So yeah, that's not very very helpful. So the same, I can run, let's say, ls, and I can see something there. So it was approved. While it's doing something, we can click simulate and we can see that it was actually approved. And then we can hide it. And now we're waiting for this command to prepare an environment, and it is performing. So performing is a synonym of executing task. And it was executed, and this is a result of this command. So there is one file. So as you can see, it is quite a straightforward way to control a large amount of things in Spacelift. And task is very helpful if you combine it with the way of executing just a loud subset of commands. So Terraform destroy should not be allowed, for example, but Terraform import of resources of specific type can be a good idea, for example. Okay, so that's it. Now let's move to some black magic. The black magic will be about the way how I handle dependencies in Terragrunt or Terragrunt dependencies in Spacelift. So to explain it one more time, I have folder or stack GitHub files, which is dependent on GitHub main, which is located one level up. In terms of GitHub, you may think about it as one stack, which is GitHub main, controls the repository itself. Let's say it controls labels, it controls certain access things, and GitHub files controls just files which are located inside of that repository. So in the future, I plan to expand this to control same file which we have to update quite frequently, like pre-commit hooks, license, and GitHub action configurations, because we want them to be as similar as possible. Salute всем. Well, yeah. Hello everyone. Hello Igor. Let's see. There was a question by someone. Spacelift seems like ArgoCD for Terraform. Would this be an incorrect or incomplete analogy? Spacelift is, yeah, well, I guess it is a rather similar analogy. I just wanted to say that Spacelift is doing, let me show somewhere here. It's here. Spacelift works on different platforms as well. So it can actually do a large amount of, well, not large, pretty much everything with Terraform, with Pulumi CloudFormation, and quite recently there was an addition of Kubernetes. So you may look into that one like as a replacement of your ArgoCD. But well, of course, ArgoCD exists for slightly different reason. But yeah, Spacelift support it as well. 1 second. Okay, let's move on. Right, so now let's look into black magic, more specifically in the code. So what this code is doing. Well, GitHub files has dependencies on GitHub main, right? So let me show the configuration which I wrote and just explain it briefly what's happening. So this was the way how I implemented it last time, where I didn't respect any dependencies. Everything was located inside of Terragrunt HCL files. So I was just looking for Terragrunt HCL and add them to depends on labels, which triggered Spacelift to respect those dependencies at the very end. So once something was finished, then it was triggering something what is depends on it. That's it, but it's another way with Terragrunt. With Terragrunt, we need to do slightly different things. So what I do here is that I'm extracting all information about Terragrunt HCL files, and I keep only folders there, and I keep once I know where these folders are, then I go through dependencies. Dependencies itself, that's another piece of magic which I even don't put so high because it's a little bit magical. What exactly is doing this guy? While I'm going through all Terragrunt folders, I'm executing this command Terragrunt render-json into a specific file name, and I don't care about errors at this time because it will just work. And yeah, where is it? Yeah, and then I'm extracting dependencies path into a specific file which is called dependencies.json. So this guy is executed, and dependencies.json is produced under specific key which matches the structure of the project. So if we look into _stacks folder, same structure, but there are files rendered and files dependencies. If I look into these dependencies, you will see that it's exactly the same configuration. So it was able to extract this information. And that's the beauty of this command render-json, which I believe was added about a year ago, but not very well known by some people. So, and render-json is an output of this command, just to show what exactly is it. This specific command render-json I find extremely useful if you want to know how exactly Terragrunt is going to be executing Terraform downstream, and you will find it very useful because all of the informations here is already computed. So well, not all, but most of information here is computed, so that it was able to identify what account number I was using here. So it was able to calculate this expression and this expression and some other expressions. So I recommend to look into render-json again as a way to identify pretty much everything. What kind of dependencies, what kind of inputs will be provided to Terraform, and the way how these inputs are provided into Terraform is actually using environment variables, so that these files will be, that's kind of off topic, but still it's rather relevant for some people. Files equal, and then this is map, so it will be something like this. So this is it, and then Terraform apply. So this is how Terragrunt will pass this value, and Terraform will be able to catch it. Yeah, what else? A bunch of other arguments are here which you may find useful for your own scripting. Yeah, that's it. So in our case, I'm interested in just this guy on dependencies pass, and I'm able to generate it. So this is the point of null resource. It's producing a couple files, and that's it. And let's look further. So once we have this dependencies JSON file, then we are again doing similar thing, reading content of all of this dependencies JSON file, converting null into empty list, just because it's easier to work with the same type of structure in Terraform. And then I'm just converting this relative path /main into an absolute path, and I remove or strip repository root to match it to Spacelift stack project root, so that absolute path is then converted into something what Spacelift is able to understand. So why I'm doing this? Well, the idea is the following, that Terragrunt code is using this thing so that when I go to this project folder and I run Terragrunt apply all, it will be able to go through this path and do whatever is necessary. On Spacelift, on another side, there has to be a little bit more magic happening. So once I'm having all of these folders as a map, then I instruct Spacelift stack to actually call or to do what Terragrunt natively should be doing. So if there are dependencies on specific stack or in specific stack, then I'm going to execute Terragrunt run all apply, and without interactive mode, it means that it will say yes, yes, yes to everything. There are a few things. Let me show here in the configuration of this. Right, so inside of planning, so that's pretty much how it ended up in UI. So of course I configure it through the code, but it can be also visible here. So the way how GitHub files dependencies were kind of converted into is I execute Terragrunt run all, and then Terragrunt run all apply will be performing apply in all dependencies. Apply here and planning here is not exactly a good match. And why it is not good match? Well, because if you are planning something, it does not mean that you are going to apply it. I didn't find better way to do this in Spacelift, and well, there is no easier way to. It's like to put square boxes into what is it, into round shape or whatever. You get the point. But it works. It works okay for my case. And to be honest, I wouldn't use Terragrunt in 2022 for this project. But okay, I've been using it already. So let me show how this was executed. Let's see where I can do this. Yeah, I guess I can do this here. All right. Approval. Is this output? Yeah, I think that's correct output. So this command Terragrunt apply all was executed here correctly, so that when I plan changes inside of GitHub files, it was actually able to execute this command in level up, and yeah, that's how it is. So nothing specific to look into here. Well, let me maybe explain one more time why I think this is black magic, why it should not be doing this way. Yeah, it's probably a good idea to look into the code. So one more time, I think it's very hard to explain actually without showing some diagrams, but imagine that you rely on Spacelift to handle all of dependencies and all of your policies, and you're happy with it. And then another guy comes to you and say, hey, we're using Terragrunt, and you are like, oh my god, why do we use Terragrunt? Because it's not very well implemented in any Terraform automation system. Don't worry, we can run Terragrunt from Spacelift. No, you cannot. And the way why you cannot is because as soon as you run something like this from Spacelift, it means that it will most likely disregard all of your policies which you enforce in other places. Like you may say that, I don't know, Terragrunt is not allowed to be executed, I don't know, from noon on Friday because Anton streams are happening this time and we don't want to destroy anything or any other type of policy. How I would prefer to write this one? Well, that's another, I'm glad that you asked, so let me show another command for this. How to, yeah, okay, I can show this one here. I guess it's going to be fine too. So if I run this command instead, well, it's going to be format list like this. So what this command is doing, imagine that there is a spacectl command which I install. Well, eventually it will be available inside of default runner, but it's not available. So meanwhile, you need to install it like this. Once you install it there, then you can control the execution of certain hooks before plan, after plan, before apply, after apply, and there are a bunch of other hooks just by calling the spacectl stack deploy and tell what kind of stack you want to do and whether you want to wait and tail for output. So if you do it like this, then spacectl effectively will be enforcing and will be evaluating all other policies on behalf of you. And I think it's a much better way than suddenly break into the loop and start calling Terragrunt or Terraform or whatever other tools. It's just gonna to break and gonna to look very terrible. Well, it's kind of easy to make it look terrible, to be honest, but it will be looking more terrible. or terrible. Right. Let me show another thing, which is somewhere here. Let me. Yes, of course you don't see it. Here is it. What is it? Yeah, I think this is it. 3 hours ago. Was it me? Yeah, right. It was me playing today. Okay, so this is actually an example of how this API call using spacectl may look like. That's why it's started 3 hours ago. Yeah, right. Started 3 hours ago by this API key. That's because I was calling it from Spacelift itself. So yeah, nothing really special here, but the cool part is that everything is tracked and you can see what exactly has been executed. So started by not my name but by some API is the way to see how or what was actually executed. Right. Okay. Do I have any questions, or is it so obvious? Well, I guess it's not so obvious, but still, this one is another cool way of seeing what has happened. When you have a lot of stacks here, then, well, for me, actually, the only problem here is that I don't read from right to left. I don't know, maybe some of you guys read from right to left and you find it more appealing. I would really kind of expect it to be another way around. But that's the only thing which I have in terms of feedback. So here you can see that me was triggering something, and you can see what kind of stacks I was calling. You can see what kind of state they have, like final state. They can be finished or they can be failed. You can see commits happening here, that they were also triggering something. So yeah, that's kind of cool. You can also group them by stack. No, not by stack, it's kind of boring in this case. Yeah, branch state. Yeah, no, actually, yeah, trigger is the easiest one. Maybe if I show it for last 7 days, it will be a little bit more. Yeah, but the point is the same, that I commit seldom, but I run. Yeah, but I run it locally, or not locally. I run it through UI quite frequently. Sometimes you will see that there was a commit, and then this commit triggered one run inside of one folder, one stack, and this one triggered another one. So this is also helpful. When you have a lot of these things, you can do quite a lot. Also, you can click bulk action and, well, not in this case, but if I look into stacks and select, let's say I select all of them, and I click bulk action and trigger. It's kind of handy to be able to just trigger all of them or log all of them. Yeah. Okay. Well, okay, if you don't mind, let me show you another magic tfcli. It's kind of cool to see this project happening pretty much the same time as I'm making this stream. So why I'm showing this? Well, I showed this probably a bit too many times because Terraform-in-Terraform is essentially what we are trying to do in many cases, right? We try to call, well, like if you are doing something very normal and very expected, then your life will be boring very soon. As soon as you try to, hello Ilham, as soon as you try to call, let's say, one stack from another stack, or you want to or you want to get some workarounds about Terraform not being able to interpolate some values in places where you wanted it to be, or many other things, you will start to come up with ideas or with thoughts that, hey, I want to call Terraform a little bit more dynamically. And this project where Terraform-in-Terraform was kind of created is towards the same goal, where we want to be able to control or to kind of interact with Terraform a little bit more effectively, I would say. Can you tell me, there is a question, can you tell me please which IDE do you use? Well, I still use IntelliJ IDEA with this one. This is it, Ultimate Edition. For non-commercial open source development only. Oh yeah. Okay, so yeah, you can use IntelliJ or VS Code. They have some sort of Terraform plugins available. Yeah. Okay, and Maxim, hello Maxim, you're the only guy who is watching this on Twitch. So maybe there is a default setting for Jewish people that you need to change in order to read from left to right. Yeah, maybe. Yeah, it's like, yeah, when you open an account, how do you want this to be shown to you? And you have to select from left to right. Yeah, that can be an option. No, but actually it makes sense because stuff is being added and then it's being pushed away. So same way as GitHub branches or GitHub network is visualized. Okay, right. If I don't have any other questions, I don't think I have a lot to show here other than it works and it will be even better in the future in terms of Terragrunt support. But currently it is a little bit magical. So you need to really consider whether you want to use Terragrunt in first place. And I actually regret that I used Terragrunt with Spacelift for this series of episodes, specifically because I have to struggle with some things which I would not like to struggle in 2022. But again, it's not problem of Spacelift, it's problem of Terragrunt implementing things slightly different than the rest of Terraform. Yeah. Okay, what else I wanted to show, actually quite cool, but it's not available for public workers. Let me just explain it, and I'm pretty sure that you guys will appreciate it as well. So imagine the following. This content of stuff which I was maintaining is going to be drifting over time, right? I mean, as everything, at some point, someone will go to UI and change it, and then next time there will be a drift which I need to reconciliate somehow. The way how this can be done in Spacelift is quite simple. You go to stack, which you want to do. Of course, you can do this using Terraform, but I'm going to show it here. You go to settings, integrations, and select drift detection. And drift detection means that every 15 minutes, or you can add another cron field here, will be executing the same Terraform plan or Terragrunt plan, and you will be able to see the output of it, and you can react on it the way you want it. If you want to even run Terraform apply, you can just select the reconcile button and then it will be applied. If I click yes, now it will be error. And the error is because it's not supported on public worker pools. And I'm using public worker. Well, if you have paid account, you will be able to get to make your own private workers, which will be executing Terraform in your infrastructure, and that's where you can have fun and do pretty much anything you want on public workers, on private workers. You can install a bunch of different things, you can integrate it with your networks and so on. So right now it's not possible, but I think it's quite cool. And yeah, and of course you can see what exactly and how exactly this was drifting. I don't have anything, but you have good imagination, I'm sure, that will be shown here. Well, yeah, I think I showed most of features which were applicable to this project, Spacelift Meta. If any of you have any questions about Spacelift, you can ask me or you can ask guys from Spacelift. They know this stuff much better than I do. But well, as usual, you can reach out to me. I'm not gonna to bite you. And yeah, that's pretty much it. Okay, that's it for today, and thanks everyone for watching, for attending, and for asking questions. Wish you to have a lovely day. See you. Bye.